Hi students, today we can continue with the chapter acids, bases and salts, and today we will be discussing about the chemicals we are obtaining from the common salt. We know common salt is neutral salt formed by the reaction between HCl and NaH solution, and it's very easily can be prepared from seawater by drying it. And it is also available in the form of rock salt. Deposits of crystals of solid salt are found in so many parts of on the earth crust. Then the common salts, which is used in food, we know, and it is also raw material. That means we are going to prepare these chemicals like sodium hydroxide, baking soda, washing soda, bleaching powder, etc. from the common salt. We'll be studying one by one. Okay, the first one we are going to study is chloralkali process. Chloralkali process, the single process gives you three chemicals. Okay, see the picture, observe the picture. It is shown a container having brine. Brine means aqueous solution of sodium chloride. Okay, we have two electrodes, anode and cathode. Then we are taking aqueous sodium chloride solution, that means brine. That means we have 4 ions in it: Na plus and Cl minus from sodium chloride, H plus and OH minus from water. Okay, so during electrolysis, the cations, the Na plus and H plus will move towards the cathode, and out of that hydrogen wins the race. So we'll be getting hydrogen at the cathode during chloralkali process. Whereas towards anode, the anions will be moving, chloride and OH minus ions, and with that chlorine wins and we get chlorine at the anode. And the remaining Na plus and OH minus ions, that means NaOH, we are getting at the bottom of the container. Okay, this is what is happening during electrolysis of aqueous sodium chloride. Okay, and the equation is showing here. And 2NaCl plus H2 gives 2NaOH plus Cl2 plus H2. That is a chemical equation of that chloralkali process. Okay, now we'll be studying the importance or the uses of these chemicals one by one. Uses of NaOH, it is given degreasing of metals to make soaps and detergents. This washing soap is prepared by sodium hydroxide, and for paper making, artificial fibers, etc. Then chlorine is used for water treatment in swimming pools to make PVC, polyvinyl chloride, PVC, disinfectants, CFCs, chlorofluorocarbons, and in many pesticides chlorine is being used. Then hydrogen is used as a fuel to produce margarine, means artificial butter, to make ammonia for fertilizers. Okay, urea and all is made from ammonia, which is made from hydrogen in turn. Okay, so these are the importance of these chemicals we obtained from chloralkali process. Okay, now the next compound or next chemical we are going to prepare from common salt is bleaching powder. See, the formula is CaOCl2, calcium oxychloride. Okay, what you have to do is chlorine acts on dry liquid. So what do you have to pass chlorine gas through dry is very important, dry slaked lime to get bleaching powder. CaOH twice plus Cl2 gives CaOCl2 plus H2, calcium oxychloride, which is bleaching powder. Okay, actually the composition of bleaching powder is very complex, but we have to keep in mind the formula CaOCl2. Okay, then the next is given the uses of bleaching powder. Bleaching powder, the word itself gives some of the uses. It is used in the bleaching industry, bleaching purposes. It's used for bleaching cotton and linen, wood pulp, washed clothes, etc. And also it's used as an oxidizing agent in many chemical industries to make drinking water free from germs. Okay, so these are some of the uses. See, the effect of bleaching, the dark colored substances or the whatever it is, if it is food pulp or whatever it is becoming bright white like this after bleaching. Okay, so it is chlorness or bleaching powder becomes very important. Now the third chemical we are going to prepare is baking soda. Baking soda is NaHCO3, sodium bicarbonate or sodium hydrogen carbonate. Okay, see for the to prepare baking soda we need NaCl, water, reaction between NaCl, H2O, carbon dioxide and ammonia. We are getting ammonium chloride and NaHCO3. Okay, NaHCO3 we can take, that is baking soda. Actually it is a non-corrosive mild basic salt only, and this is used baking soda we know it is used in baking purposes. While baking cakes and all we are using this, and how it is working, see the equation gives the answer for that. What happens when we heat this baking soda, it decomposes to Na2CO3, sodium carbonate, water and carbon dioxide. Carbon dioxide, so when we are preparing or making the batter for cakes and all, we'll add a pinch of baking soda into it, and while baking what happens is on heating it changes to produce carbon dioxide, which leaves gaps in the batter on after cooking, then making the cakes and all spongy. Okay, so that is why we are using this baking soda in the cake industry and all, right? So it is given use of baking soda to make tasty crispy pakoras. It is also added for faster cooking to make baking powder. That is another important thing, baking powder. What is the difference between baking soda and baking powder? Baking soda is nothing but NaHCO3, whereas baking powder is baking soda plus a mild edible acid such as tartaric acid. Why a mild edible acid? Because we learned that on heating baking soda it gives carbon dioxide and sodium carbonate. But see, if you add a mild edible acid instead of mm, uh, simply taking carbonate, we are getting, instead of sodium carbonate we are getting sodium salt of that mild edible acid. Okay, so that gives a sodium carbonate is a base which is not healthy for our stomach, so we can avoid that problem by making baking powder by adding a mild edible acid, okay, into baking powder, so that it becomes baking powder. Baking powder is a mixture of baking soda and mild edible acid. Okay, now it is used in ingredient antacid, oat baking soda. Baking soda is used as an along with magnesium hydroxide, milk of magnesia we are adding baking soda also. Okay, then used in for soda acid fire extinguishers. See this is a picture. In this we are using baking soda. So baking soda can be used. See baking powder. This is making the cake fluffy. This is antacid. Picture of antacid is shown here. Now the next compound we are going to prepare from common salt is washing soda, or the formula is Na2CO3 dot 10H2. Okay, we'll study this, why this dot 10H2 is given. Anyway, how to make it is I'll tell you. So from NaCl we can prepare so baking soda. Baking soda on heating we are getting sodium carbonate. That on recrystallization with water we can produce washing soda. Okay, so baking soda on recrystallization with water we can produce washing soda. Means sodium carbonate plus dot 10H2O is washing soda. And where it is used? It is used in glass, soap and paper industries, used in the preparation of borax, used as a cleaning agent in domestic purposes, then to remove permanent hardness of water. Permanent hardness of water can be removed by using washing soda. Okay, so keep in mind it is not baking soda, it is washing soda is used to remove permanent hardness of water. Okay, so that is washing soda, Na2CO3, 10H2O. Then why the 10H2O? We'll discuss. See, for that, we'll take a copper sulfate, CuSO4. It is having, we are going to prove that it is having water molecules in it. So first we will take blue crystals of copper sulfate, then we'll heat it. See what is the change happening in the picture? The blue color is changing into, turning into white, right? So why it is so? Or take the test tube, then add 2 to 3 drops of water into it. So we can see that the color is going back to blue. So what is the change happening? On heating, the water molecules attached to copper sulfates get escaped or get removed, and the color disappears. On adding water again, the crystals regain its color. Okay, so that crystal, that drops of water molecules are called a water of crystallization. Copper sulfate is having 5 molecules of water, which we call it water of crystallization. So if that 5 molecules of water are there only, the copper sulfate are having the blue color. Okay, it is called the blue vitriol. Only in the presence of, or only in presence of, or only under hydration, this copper sulfate has the blue color. Okay, then definition of water of crystallization is given. Water of crystallization is the fixed. It is fixed for a particular salt. For example, it is 5 water molecules for copper sulfate, 10 for washing soda, 2 for gypsum, like that. Okay, the fixed number of water molecules present in one formula unit of a salt is called a water of crystallization. We call it hydrated. Okay, we can use the word hydrated along with the salt. Hydrated copper sulfate, hydrated sodium carbonate. Okay, hydrated copper sulfate is blue in color, and the water of crystallization is 5 molecules of water for copper sulfate, 10 for Na2CO3, 2 molecules for gypsum. Okay, this is water of crystallization, and we use a dot to separate the water molecules present in that, to show the water molecules present in it. Okay, so that is water of crystallization. We can represent by adding a dot and the number of water molecules. Now another compound is plaster of Paris. Plaster of Paris is prepared by heating gypsum. This is gypsum, CaSO4 2H2O is gypsum. So this equation, the reverse equation, gives you the preparation of plaster of Paris. Heating gypsum, take this compound, heat it, you will get CaSO4 half H2O. That is what is called a plaster of Paris. The reverse equation, by the reverse equation, you can prepare plaster of Paris. What do you have to do? You have to heat gypsum. What is the temperature to be maintained? 373 Kelvin. What happens? It loses water molecules and becomes a white powder. We call it plaster of Paris. Okay, plaster of Paris on mixing well. We have to keep this plaster of Paris in a closed container. Otherwise, what will happen? It takes water molecules from the atmosphere and changes back to gypsum. Okay, from where we have prepared it. So plaster of Paris is CaSO4 half H2O. It takes water molecules from the atmosphere forming gypsum. So it should be stored in a airtight containers. Okay, it is only half, it is shown here, but actually 2 molecules of calcium sulfate is combining with 1 molecule of water. That is the real combination, but when we write the equation, we are writing half. When we are writing only CaSO for only 1 molecule, so half H2 we have to show. Okay, so that is the next compound, plaster of Paris. Uses, it is used, the pictures showing very clearly the uses. Plaster of fractured bonds, to plaster the fractured bonds, making these ornamental items like this, to make toys and for decoration, to make these window panes and all, to make surfaces smooth like this. If there is a irregularity in the surface of the walls and all, we can use the help of this plaster of Paris. Okay. And these are the uses of plaster of Paris. And plaster of Paris gets its name from large gypsum deposits in Montmartre in Paris. That is by the name plaster of Paris. The plaster which is available or which is obtained from Paris, that is by the name plaster of Paris. Okay, see some of the what is shown here is some of the chemical compounds and their common name and the formula. See, sodium hydroxide, it is called a caustic soda. Sodium carbonate, washing soda, if there is 10 more H2O is there. Carbon dioxide, if it is dry, we call it dry ice. Then sodium bicarbonate, it is called baking soda. Then calcium chloro hypochlorite, it is bleaching powder. Then it is calcium zinc sulfate, it is white vitriol. Copper sulfate, blue vitriol. Ferrous sulfate, green vitriol. Sulfuric acid, oil of vitriol. Okay, then calcium oxide, quicklime. Then calcium sulfate hemihydrate, that is plaster of Paris. Then sodium chloride, we know it is table salt. Then we know calcium sulfate dihydrate, that is gypsum. Calcium hydroxide, we already learned, it is slate lime. So this is a table which many of the chemicals are coming in this lesson with their common names. So it may ask for a one more question for the public exam, okay, board exam. So that's all for this video. We will discuss the board questions in the coming video. Thank you.